Let's consider the water molecule, which has the following Lewis dot structure. Now there are 4 total electron pairs around oxygen, 2 non-bonding electron pairs and 2 bonding electron pairs, and so that gives 4 total electron pairs. And so with 4 total electron pairs, the electron pair geometry around the oxygen would be tetrahedral. Those 4 electrons pairs get the farthest away from each other by assuming a tetrahedral geometry. But only 2 of those electron pairs are bonding, and so if we draw just the atoms and their geometries, we would have this shape for the atoms in water. The 2 electron pairs are here and here, and they come out at us. One comes out at us and the other goes away from us behind the paper. But just the atoms form a plane, and so the water molecule has a bent molecular shape to it. So it's not linear because of the geometry of the electron pairs. So there are 2 geometries that we want to consider. Electron pair geometry, and that includes bonding and lone pair, or we call them non-bonding sometimes, electrons. So all the electron pairs bonding and non-bonding around an atom. Then we have the molecular shape, and that only includes the atoms in a molecule. Let's consider another example. Let's consider the ammonia molecule. So if we draw the Lewis dot structure for ammonia, it would look like this. Now ammonia has 1 non-bonding plus 3 bonding electron pairs, so that's 4 total electron pairs. So the electron pair geometry would be tetrahedral. But what about the molecular shape? Well, if the electron pair is tetrahedral, then if we drew the molecular shape, 1 hydrogen would be coming out at us, the other 2 hydrogens would be going away from us behind the paper. So I'll try to draw them with these wedges to give you an idea. And so if you look at this shape of ammonia, this is a 3-sided pyramid. The hydrogens sit on the ground and the nitrogen sits at the top of the pyramid. So this is called trigonal pyramidal. It's a 3-sided pyramid, the trigonal, and it is pyramidal because of the shape of the pyramid. If we had the methane molecule, so if we draw the Lewis dot structure for methane, CH4, it would have this Lewis dot structure. There are 4 total electron pairs, so the electron pair geometry is equal to tetrahedral. And the molecular shape is also tetrahedral because there are 4 bonding electron pairs. Now another example we used in Lewis dot structures was sulfur hexafluoride. So here we have 6 fluorines around sulfur. So this would be the Lewis dot structure, not putting all the dots for the fluorine lone pair electrons, but we're just considering the sulfur atom. So we have 6 total electron pairs around sulfur. So the electron pair geometry is octahedral, and the molecular shape is also equal to octahedral because we have 6 bonding pairs. So you might notice that whenever we don't have any non-bonding electrons, the electron pair and the molecular shape geometries are the same. Let's consider carbon dioxide. We saw that we have an Lewis dot structure that looks like this for carbon dioxide. So what is the geometry around the carbon atom? Only count single bonds toward the electron pairs around an atom. So carbon has one single bond here, another single bond there, so it only has 2 electron pairs around it. We don't count the second bond. So with 2 electron pairs, that would be a linear arrangement. So carbon dioxide has a molecular shape of linear. Dioxide would be linear, whereas water has a bent shape. As a final example, let's consider the NO3- molecular ion. So the Lewis dot structure for the NO3- ion would be I'll draw lines for the electron pairs, and we have a negative total charge. So we're going to count the bonds, electron pairs around nitrogen. So there are 3 single bonds around nitrogen. We don't count double or triple bonds. So 3 single bonds, so we have 3 electron pairs. There are no non-bonding pairs around nitrogen, so that would be trigonal, a triangle, planar. So that's the molecular electron pair geometry for 3 electron pairs, trigonal planar. So since there are no non-bonding electrons, the molecular shape would also be trigonal planar. So the nitrogen and oxygen atoms lie in a plane, say the plane of the paper, and they form a triangle.